but I need a way in which the logic and longevity be optimized for
Not today.
Hello and welcome. If you're a fan of rock formations and clean energy, and honestly, who isn't? You're in for a treat. Picture this: a world where we can harness the power of natural hydrogen without needing to beg our planet for forgiveness. Intrigued? So am I. My today's guest, Eric Gaucher, is the founder, CEO, and leading geoscientist at Lavoisier Hydrogen Consult. He has extensive experience in water-rock-gas interactions and exploring natural hydrogen. His pioneering work has significantly advanced the understanding of natural hydrogen as a viable and clean energy source, positioning him at the forefront of this emerging field. Eric's insight into the geological and geochemical processes that produce and store hydrogen in the Earth's crust are invaluable to the ongoing efforts to harness this potential energy resource for the future. Eric, welcome.
Thank you, Arnaud. Thank you for your invitation.
For the beginning, can you tell us who is Eric Gaucher?
So at first, I am a French researcher working in this field of georesources. So I've worked on geothermy and also storage of CO2. But since several years, I am working on this new field of natural hydrogen. So it's a new subject, and I think a very promising energy source. And so I am trying to develop this as much as possible.
What chemical reactions produce natural hydrogen in Earth's crust?
You have several ways to produce hydrogen in the Earth. At first, you have the primordial hydrogen, so the hydrogen that was stored during the formation of our planet. So it can be interesting also, this very primordial hydrogen. But then you have several other sources that are redox reaction with iron 2, mainly iron 2. So when you have iron 2 in some minerals, when you dissolve them, then the iron 2 is able to capture the oxygen, and this capture of oxygen in the water produce hydrogen. So if you remove O to H2O, you have H2. So you have this production of hydrogen with the redox reaction. And another way to produce hydrogen is done by radiolysis. So the natural radioactivity of the Earth with uranium or thorium is able to break the water molecule, and you have a production of hydrogen this way. So that's the three main production of hydrogen. We can also imagine to produce hydrogen with organic matter, with coal in the Earth, but it's not so common, not everywhere, and that's another way to produce hydrogen.
Can you discuss the role of water radiolysis in natural hydrogen production and the types of rocks that facilitate this process?
Yeah, you have when you have a concentration of natural radioactivity, and with radioactive elements like uranium, thorium, and also some potassium-40, you have this release of radiation, and those radiation are able to break the water molecule. And then you have this production of hydrogen this way. This is well known, for example, in the Cigar Lake mine in Canada, where they have observed a huge quantity of hydrogen. That is, for them, a safety problem. But we can imagine to produce this hydrogen too.
What specific geological features are reliable indicators of white hydrogen presence distinct from hydrocarbon reservoirs?
In fact, you don't find hydrogen where you have oil and gas, the natural gas. In sedimentary basin, you have almost no chance to find natural hydrogen. You need to find another type of rocks. So rocks that are iron 2, so the ferrous iron rich, or the rocks that are that have this natural radioactivity. So we have, and the geologist knows where those type of rocks are at the surface of the Earth or in depth. And the challenge for us for this natural hydrogen quest is to find those rocks. And but with the geological map, we have a nice proxy, and we can say, okay, we have nice places where we should find hydrogen. The problem is not only to find the kitchen where the rocks that can produce hydrogen are, but also to find some reservoirs. And that's the challenge we have now, is to combine and to explain all the hydrogen system. And an hydrogen system, a natural hydrogen system, is a kitchen where the hydrogen is produced, some migration pathways with fault, for example, and some traps. And those traps are reservoirs that could be classical reservoir, as we have for oil and natural gas, or unconventional reservoir with other type of rocks. For example, in the Mali case, we have volcanic rocks that are good traps for hydrogen, and the hydrogen is present because you have a trap, and the cap rock of this trap is made with a volcanic rock.
So can you explain, just for our audience, the difference between the traps and seeps?
Yeah, in fact, you in a hydrogen system, so you have a system where you can concentrate the hydrogen in a reservoir. So in the porous media, it's very like what we have for oil, for example. And when your reservoir is completely filled with natural hydrogen, then you have a spill point where you have some a part of the hydrogen that is escaping and can follow again the migration pathways that are the faults, the main faults, and you can observe seepages at the surface. So that's why in the exploration of hydrogen, we are looking for the gases that are expressed, that are produced at the surface, at the Earth's surface in the soil.
What role do geochemical models play in predicting the presence and behavior of hydrogen in different geological settings?
Yes, I think it's geological model and geochemical models can be very important, because you can calculate all the kinetics of production of hydrogen. So you have a type of rocks, you have water, access to water, and you can calculate, because of the kinetics of dissolution of minerals, you can calculate the amount of hydrogen that is produced during a period of time. That's the first part of the model. And then you need to calculate also your all the hydraulic processes, so the fluid flow, including hydrogen, in your hydrogeological system. So the migration, and then you can calculate with, for example, the seismic image of your underground, you can calculate the volumes of the reservoir you suppose to have in the subsurface.
How are unconventional data sources like microbial signatures used to refine white hydrogen exploration models?
That's a good point. I think for the moment it's only research, but we are thinking that some microbes are very familiar with the hydrogen ecosystem. So then if you find those microbes, you have a good way to detect hydrogen in the environment where you have this type of microbes. So this can be a new way to find hydrogen using the biological signature, the microbial signature linked to the hydrogen, mainly in the soils, but maybe in the aquifers also. So if you have access to water samples, you can make the microbiology in the water samples. And if you detect some microbes that are familiar, that have a very easy way to work with hydrogen, you will have a good signal. So you will know that in the surrounding of your water sample, you should have a hydrogen system.
Since it's still in the research phase, can you provide examples where geochemistry or microbiology led to identifying overlooked white hydrogen prospects?
Yes, for geochemistry, we have plenty of examples now of soil gas measurement. So when you are doing a measurement of the different type of gases you have in your soil, you can detect hydrogen directly, and also some gases that are familiar, that are common with hydrogen. So you, for example, helium, high concentration of helium can help you in this research. But also, if you are working on radiolysis of water to produce hydrogen, you will find also radon, a radioactive gas. So you have some gases that are associated to hydrogen and can help you to interpret the data you have concerning the soil gas analysis. That's the first point. And for microbes, I will say, for example, I know that there is a research program trying to develop new tools with microbes, but they are in the infancy for the moment. And I don't think I have read a paper explaining that using this type of microbe, we have made a good detection of hydrogen. This is the future, and a very not very far, but it's not operational for the moment.
You already mentioned some, but what methods are currently used to detect and quantify natural hydrogen, and how reliable are they?
So the idea, and I am also a geologist, is that you will combine geology, tectonics, geodynamics. So you need to explain what is your geological system to find then the right rocks, the rocks that are able to produce hydrogen. And for that, we are using another science of geology, is petrology. So petrology is the science of rocks. And then, so that's the first part, so pure geology. And then so with the geology, you can say, okay, this area is favorable or not to the production of hydrogen. And then you are using geophysics, so seismic image, to have a good view of your subsurface. But also you will have, we will use, because for example, we are working on very heavy, on magnetic rocks. So when you have mantle-like rocks, so the rocks from the mantle, and where they are producing hydrogen, their transformation gives you magnetite. And magnetite is very interesting minerals because it's a very magnetic mineral. So the magnetic signature of the rocks that can produce hydrogen, in the case of the serpentinization of the mantle-like rocks, so this signal, this magnetic signal, is so huge that you know precisely where is your kitchen, where you produce magnetite, you know precisely where you produce hydrogen too. And so with the geophysics, you can have this delineation of the place where the hydrogen is produced. And then you have also the geochemistry, and the geochemistry, so the soil gas analysis in soil. And also you can degas the aquifers. If you can sample the water in your deep aquifers, then you can analyze the gases. And with the gases, you know if you have hydrogen or not in your system. So we have several tools, and when this combination of tools is the work the people are doing to say, okay, I have not only seepages at the surface, but a real hydrogen system. So with a kitchen, with migration pathway, with a trap, a reservoir, and some seepages to the surface.
What are the limitations of traditional geological models in predicting white hydrogen?
I think for the moment, we need to have a success, and we need to find a very large accumulation. And this, and when this will be done, we will calibrate our models. For the moment, we are not at. It's still natural hydrogen is still a subject that is in research. It's not completely operational. We have good example where we suppose we will have a large success on large volume of hydrogen, but the final demonstration that those large volume exist is not done for the moment. And when this will be done in the next 3-4 years, it's very important to study the first cases very carefully and completely in order to calibrate the geological model. And the first success will be very important for this calibration, and this will be a great help for us to continue this research and this exploration for natural hydrogen.
Talking about models, how are geologists adopting methodologies without robust statistical models for white hydrogen?
In fact, I think we have a lot of tools that are already on the table, and we need to just to adapt them because hydrogen is another molecule. It's a small molecule. So the diffusion of hydrogen is very high in rocks, and we need to calibrate also the diffusion of hydrogen, because we need to quantify if we are losing a part of the hydrogen that is produced in those kitchens, and all of this need to be calibrate. And the geologists need also to change their mind. They were working on oil, for example. So oil is a very viscous material. On the flow regime of oil is very slow, and probably hydrogen move very fast in the porosity of the rocks. So we need to change a lot of parameters and to adapt our models to a new matter. And we need also to change our mind because probably we will find something completely new, on the way we will change our mind in this exploration is very important. So it's we are on the learning curve for the moment. We are not at the end of this subject, just at the beginning.
We are going a bit granular here, but I think it's very interesting. What are the most promising advancements in remote sensing for detecting subsurface white hydrogen, and what are the key challenges to their adoption?
The study of the images from satellites are very important to detect some places where you can have some hydrogen seepages. What we call the fairy circles is a structure that is like a tube, and you see at the surface a circle, and they are like a chimney of hydrogen. And in old cratons, so in the old rocks of the Earth, where probably the radioactivity play a role in the production of hydrogen, you have at the surface some those figures where you can detect from space interesting places, but you need to go on site in the field and you need to detect the hydrogen with a gas detector to confirm that those circular structures are really linked to hydrogen or not. And that's a first point. But hydrogen is emitted not only in fairy circle, but also on classical fault, and you don't see anything from space with the remote images from satellite. So the fairy circle is only one cases, more linked to the old cratons of the Earth, but there is other places where you can find hydrogen without any signal you can capture from space.
What specialized geophysical methods are used to identify tectonic faults for white hydrogen exploration?
Yes, we need to combine seismic imaging with gravimetry and with magnetism, and with those three methods. And if you combine the three signals, you will have a nice data set that will help you to understand where you can produce hydrogen and how your hydrogen can move in the subsurface, and to identify the reservoir where hydrogen should be trapped.
How can exploration techniques for oil and gas be adopted for natural hydrogen exploration?
A lot of them are very interesting for us, and in fact, we are using the same tools as the geologist or the geophysicist are using for, or geochemists are using for oil. It's just to move from a sedimentary basin to the border of sedimentary basin, or to completely other places where mining activities are more common, because hydrogen is linked to the metals. So I am now working with the mining industry, because for a lot of places you have the rocks that are interesting for the metallic ore, but can be also interesting for hydrogen. So in fact, we need to adapt our tools, our classical tools developed for the mining industry, for the oil and gas industry, to a new subject. But we have already a lot of tools that are available, are very useful for this exploration. And in fact, we need to continue to develop new detectors on permanent detectors, for example, and a huge effort is done by several companies in this area to have a cheap and very efficient hydrogen detectors. But if you can add the other gases that are interesting for the hydrogen exploration, this is interesting also. So several companies are developing good gases detectors. You can let for a long time on a fault, for example, to follow and to study the fluxes of hydrogen in the main fault, in the tectonic faults, where we suppose that we have a migration of gases from very deep part of the system, of the subsurface.
I'm aware that this technology is still in the infancy phase, but what advancements have been made in drilling and extracting natural hydrogen tech?
In fact, in the places where hydrogen has been detected in large quantities, for example, in Mali, for example, in Albania, and what we have done in the Pyrenees, for example, we are using technologies that already exist, but we need to what we need is with those technologies to detect the artifact we are doing during the exploration. For example, when you are doing a soil gas analysis, you need to produce and to drill a small borehole with a portable drilling machine, and if you have a lot of quarks, so a lot of quarks and water in this system, you can produce artificial hydrogen. So we need to detect artifacts. So when what you are doing produce hydrogen, and you have a wrong measurement because you are creating this artificial hydrogen. So in the last 4 or 5 years, in fact, we have already detected some artifact like that. So some data set were just wrong, because it was not linked to the natural hydrogen presence, but to the fact that the measurement method was wrong. And so we have progress, we have interesting progress in this area, for example, to eliminate all the artifact when we are doing this exploration using soil gas analysis.
When would you favor shallow wells over multilateral wells in white hydrogen exploration and vice versa?
I think for the moment, you can imagine to find hydrogen in a very shallow system. And there is some example of some colleagues, for example, in Mali, it's not very deep. So you can find hydrogen with shallow wells. But probably we will need to have deep boreholes. And my personal dream is to drill until a kitchen where the hydrogen is produced. And for example, in the Pyrenees, we know that our kitchen is around 5 kilometers in depth. So it's not it's not a so deep borehole. In the oil and gas industry, you have an example of 10-kilometer boreholes, so it's not so problematic. It's just a question of the amount of money you have to drill until 5 kilometers. And the limitation is to this risk assessment you need for your investment, in fact, on that. But if you can drill until a kitchen where the hydrogen is produced, I think you can think that you have something like a renewable energy, because the kitchen could be, in some case, so big that you will never exhaust your stock of iron 2, and then your capacity to produce hydrogen is just enormous.
Is there any data from oil and gas companies on natural hydrogen? They've done so much drilling.
Yeah, but they were drilling in sedimentary basin where you have no rocks producing hydrogen. So sedimentary rocks are not able to produce hydrogen. But below the sedimentary basin, you have granitic rocks. We call them basement, or you can find also some rocks that are iron 2 rich. So you sum that data from some deep boreholes from the oil and gas industry are very interesting, because, in fact, when we observe the data with a new eyes, in fact, we find hydrogen too. And hydrogen was detected by the oil and gas industry in something like maybe 5 to 8% of the wells. But this presence of hydrogen was not understood by the teams. And the people were thinking that you have corrosion of the metallic part of the boreholes. And they were thinking it's an artifact, it's wrong. And in some cases, that's true, that the corrosion of the metallic part of the boreholes produce hydrogen. So we have to take care about the quality of the data. But if with your hydrogen, for example, you have plenty of helium, you have a lot of CO2, so in some case, you have some methane, abiotic methane. And abiotic methane cannot be created by the corrosion of the boreholes. So this means that you have access to a data that is of high quality. And I am working on that in the Pyrenees, but also with some colleagues in Australia. And when you are doing this survey of the oil and gas literature, or all the old reports of the oil and gas, in some cases, you have very valuable information about the presence of natural hydrogen that are not artifacts linked to the corrosion of the boreholes, but are real data, and are real data that you have access to something new, and you have an hydrogen system that is proved with those data.
Let's talk about safety. How can we mitigate the risks of hydrogen leakage during exploration and extraction process?
I think the effort made by the hydrogen industry will be just transferred to our industry. We will use the same method to limit the leakages on the tanks, on the pipes, on the valves, and you have just to transfer what is known by the hydrogen community to limit and to completely suppress the leakages of hydrogen just by using the same type of materials. So it's an adaptation of the oil and gas techniques to a new molecule, a very thin and very small molecule, this natural hydrogen, but natural hydrogen is hydrogen. So all the technology that is developed by the hydrogen community will be transferred to ensure that we have no leakages, because we want to solve we need to make money with this hydrogen. We don't need to make leakages, it's just stupid. So I think the transfer of technologies that are already developed by the hydrogen industry is fundamental for that.
What potential environmental impacts of natural hydrogen production are not widely discussed?
I think a very important point is that the Earth is producing today a huge quantity of natural hydrogen. And this natural hydrogen flow to the atmosphere and contribute to the concentration of the hydrogen you have in the atmosphere today. But we don't know how much. We know that the volcanoes produce hydrogen. We know that those fairy circles produce hydrogen. We know that the big faults, the tectonic faults produce hydrogen, but nobody for the moment has made a real quantification. So we need to know that. We need to evaluate the quantities of natural hydrogen that is on a natural process, a very completely without any human actions that is done by the Earth, and give the concentration of hydrogen you find in the atmosphere because of the dilution of those natural seepages by the atmosphere. So we know this concentration, but we cannot explain it for the moment. And we need to explain why you find hydrogen in the atmosphere. And we need to develop models of natural production of hydrogen and natural fluxes to the atmosphere from volcanoes, fairy circle, big faults, and the diffusion of rocks in the atmosphere. And this is not done. So it's difficult to calculate the impact of our industry without doing that. Because we need to know if we have a big leakage on a well. Okay, we have made an input of 1 per mil, 1% of the hydrogen that is on a natural process already in the atmosphere. And so we need at first quantify the natural release of hydrogen in the atmosphere in order to calculate the human impact of the exploration and production of natural hydrogen and that will occur. Of course, we will have some leakages because some wells will fail, of course. But we need to quantify the impact. And to quantify the impact, we need at first have this estimation of the natural release by the Earth in the atmosphere.
What are the most promising regions globally for natural hydrogen exploration?
A lot of regions are promising. And we have a lot of good examples already all around the world. In fact, it's linked to the geology. You have on a lot of continents old rocks, so the old cratons, where you can observe those fairy circles. So that's the first type of areas where you can find hydrogen. You can also look to the places where you have the mantle rocks, so the rocks that are from below the crust, but in some places in the mountains, for example, or in the mid-oceanic ridges, you find those the mantle is close to the surface. So then you have a lot of places where you can find those green rocks that are able to produce hydrogen. So in fact, in a lot of areas of our planets, you can find hydrogen. And a lot of countries are very, very interesting, in fact. But in my company, our main target are the mountains, because in the mountain you find the mantellic rocks that are in an abnormal position, and so they are close to the surface and can react with the water, with the meteoric water, and then produce hydrogen. But we are also interested by very old mountains in old cratons, where those mantellic rocks are also trapped. On, for example, in the Mali, you have almost, the mountains are not very, very important, but you have the remains of old mountains, and those remains are still reactive and can still produce hydrogen. So in fact, so some people are doing now very nice maps of the chance to find hydrogen, considering one country and another. And with the geology, you have at first a first image of your potential of production of hydrogen. But you need not only to find the rocks where the hydrogen can be produced, but also the rocks that can trap the hydrogen, so can be good reservoir. That's why the border of sedimentary basin could be very interesting, because you have a salt layer or clay layer that can be good traps for natural hydrogen. And because you are not completely in the sedimentary basin where you have no production of hydrogen, at the border, you are at this limit in between the world where you can produce hydrogen and the world where you can trap the hydrogen. So the border of the sedimentary basin could be very interesting, in fact.
What geological criteria should venture capitalists consider when evaluating natural hydrogen projects? Let's say investors.
I think at first you need a training, and you can ask my company for a training. If you are an investor and you want to invest in natural hydrogen, you are not a geologist. And geology is a nice science, but you need years to learn it. So ask geological team to help you for your choice. So that's why in my company we develop a product that is to help the investors, if they have access to data and they want to have an independent review of those data, they just can ask us. But yes, you need to have geological data, geophysical data, geochemistry, and you need also to consider, of course, if you have a client not very far away of your place of production, and that can be a problem for some countries where the clients are very far away. That's why a lot of investment in Europe are very interesting, because you can put hydrogen directly on the market, and in some case you just need to you can use the network of pipes for the natural gas to export your hydrogen. So you can add 20% of hydrogen in your natural gas, and you can transport it easily. So the production of natural hydrogen in Europe or in Canada or in the States is very interesting, because you can have a good geology and also the infrastructure not very far away from your good geology and that. So yeah, I think the definition of a geological system is very important, and maybe it's why the Pyrenees case is very interesting, and for a lot of questions I have in my company are linked to that, because in the Pyrenees we have demonstrated that we have a kitchen, that we have some reservoir or potential to have a big reservoir. We have nice rocks that can play the role for trapping the hydrogen, and we have demonstrated that the hydrogen is present in the soil, but also in the aquifers. So we have a lot of data on a complete set of data, and not only solid gas measurement. So if you have only solid gas measurement, I think it's not enough for an investment. You need to have a good understanding of your geological system. And for that, you need to integrate the geology, the geophysics, and the geochemistry of your system.
Talking about the economics, what unique economic or technological factors should investors prioritize when evaluating white hydrogen projects?
I think what is expensive in a geological prospect is the well and the distance to reach a potential reservoir, and so of course the investor at first will try to invest in a project where we suppose that the hydrogen is not so deep. So the deepest, the more costly your project will be. But my feeling is that if you go deep, you also go in a zone where you have no microbial consumption of hydrogen. So if the temperature of the Earth is more than 100 degrees, you have no microbial life anymore. And then the risk of to have a destruction of consumption of hydrogen it will be very, very less important. So then you have to balance your parameters, and in a project is always like that. So the chance to find a shallow resource could be important in some places, but I think it's probably rare. The chance to find more hydrogen deeper is higher, but your investment will be higher. So yes, you need to make. I was in the oil and gas industry before in the past, and we have those table where you have a multi-parameter approach, and you try to rank your prospects. And to give them a note and to give them an evaluation to say, okay, here I am shallow, so my investment it will be low, but it's really risky because, for example, I will have some microbial consumption of my hydrogen. And if I go deeper, it's more expensive, but the chance to find a huge quantity because I am close to a kitchen or a potential kitchen is high. So then I have to balance my risk, in fact.
What are the economic implications of large-scale natural hydrogen production, and how does it compare to the other forms of hydrogen production? Or maybe better said, is there an estimate of how much one project could cost?
Yeah, we know already how to do that because the economic method of the oil and gas project could be applied to the natural hydrogen project too. So we know the price of the boreholes. For example, the boreholes are if you try to drill until 3 kilometers, you need an investment of $20 million, for example, and that's the main part of your investment. In a paper I have published last year, I've tried to calculate the price of 1 kilo of hydrogen, of natural hydrogen. And in fact, considering the price we already have in the oil and gas, we are thinking, and that's a consensus in the community, that the price will be probably below $1 per kilogram. And so it's a price we can demonstrate because we know the price of the oil and gas project.
So what regulatory frameworks are being developed or adopted for natural hydrogen exploration and extraction?
That's a very important point. In fact, you need to have an adaptation of your mining law and to be authorized to explore and to produce natural hydrogen. So some countries, and for example, in Europe, France is a pioneer in this area, but Poland has already a law for natural hydrogen. Apparently in Kosovo, it's done also. I have contact in Serbia, and in Serbia they probably will open this also in their mining law in some months. In Albania also. In Spain, you have still some difficulties because the law is not completely changed. So it can be a very limiting factor for some investment if the mining law is not changed. When it's a mining law, you need to have an explicit mention of natural hydrogen. So you can say, okay, I want to apply for an exploration for this resource, and I need to know what are the requirement of the government, what type of tax, what type of commitment I am supposed to do when I will claim for an area of exploration. For example, in the US, apparently the law is very flexible for the oil and gas and can include easily the natural hydrogen. In Australia, some state of Australia are now open with a very interesting law. For example, for South Australia, it's very clear. It's easy to take a license for exploration in South Australia. In Tasmania, it's open now. I think in West Australia, they are close to finalize the law. So some countries are very pioneering for that. And I have recently seen that in the Philippines, they have offer bids, so you can take a block, like for oil and gas, for natural hydrogen. And some places are apparently very interesting. And we know already that you have a natural hydrogen in the Philippines, and so you can bid for a block for natural hydrogen exploration. So some countries are ready now, and for some interesting places, we are waiting for a change in the mining law. So that's a first part of this question of the regulation. And next is we need to have a clear knowledge of the tax per kilogram of hydrogen. So we need to define with the government what is the part of the explorer, what is the part the state will ask for the taxes. And for this, for the moment, it's not really clear because nobody knows the volumes and so the money you will do with your project. So it's difficult to evaluate and I think for the government, it's very difficult to evaluate how much they can obtain from a project if they don't want to kill this emerging industry just by saying, okay, we will impose so much taxes that nobody will invest because of that. So that's a parameter that is not known for the moment, and it's difficult to evaluate this point, but we really need to progress also on that.
Actually, you started an avalanche of questions with this answer. But first things first, isn't it a little bit strange that, for instance, Albania is working on their natural hydrogen law and Europe doesn't have it yet?
Some countries in Europe have it. For the moment, the mining law are state by state. In Europe, it's not a common mining law for all the European Union. So it's a little bit problematic, but it's like that. In Switzerland, the mining law is canton per canton. So it's you need to, when you want to apply for exploration, you need to ask each small region. You need the help of lawyers to do that, and sometimes it's not so easy. But countries who want to help us need to adapt their mining law, and they need to maybe define for the next, I will say, 7-10 years, what can be the tax regime. And then the investor will come, and then they will produce a completely clean energy in their country.
It's very interesting to me that you first mentioned taxes and actually haven't mentioned incentives at all. Because talking about hydrogen, like the main topic is incentives and then whatever else. But in this case, it seems so logical that if there are incentives for hydrogen, that you are getting some. So how should policymakers balance the investment in natural hydrogen technologies with other renewable energy solutions?
Yeah, I think it's, you know, a lot of countries have developed programs for hydrogen, but in the mind of the people, it was only green hydrogen from renewable energy. And it's difficult for us to find our place in this landscape. And the people who have access to this money, this green hydrogen money, and they are not so happy to see a newcomer, and I can understand that. That's completely human. But this means that we need to inform at first the government. We need to make more noise about our success, our progress we have in our research and in our exploration. And then the government will balance, I don't know, part of the money they want to invest in the hydrogen economy, and let us have an access to a part of this money for pilot, for demonstrators, for more research, to have more people working in the universities and in the research centers to do that. Well, we don't speak about that, but maybe you know that I am the leader of this International Energy Agency action. So this task 49 dedicated to natural hydrogen. And in our program for natural hydrogen, we have a specific task, and this task is a roadmap for the government to develop specifically financing, public funding for natural hydrogen, because we don't want to take the money of the others. I think we need all the kind of hydrogen. If we have a huge production of green hydrogen from renewable energy, that's nice. If we want to accelerate the energy transition, we need to have that. But if we can produce natural hydrogen at the same time, we need to develop this also. And at the end, the quantity of energy will be not enough to replace completely the oil on the coal, on the gas. So we need to produce as much as possible a lot of hydrogen, and all the kind of hydrogen will find their places. And after decades, we will regulate this production. And maybe the importance of natural hydrogen will be high or not, and the importance of the production of green hydrogen will take its place also. So I think at the beginning, at the beginning of a new subject, you have a lot of pathways, and you need to explore all of them. And at the end, only one or two will be important. But you need to have this growing of options, I think. And for that, yes, definitely the government need to have dedicated program for natural hydrogen.
How can the findings from academic research on natural hydrogen be effectively translated into industrial practices?
For natural hydrogen, it's very interesting to see that what was found in the academy since 30 years was, in fact, confined to the academy. The natural hydrogen was well known by the people working in geology. I was a student more than 30 years ago now. In my courses, I have courses about the production of natural hydrogen on the mid-oceanic ridges. So in the middle of the ocean, it was known that you have this production of natural hydrogen. But in fact, you have always a big step in between the knowledge that is in the academic world and the knowledge that is in the industry world. And what we have changed since 5-6 years is that we have transferred a large part of the knowledge of the discoveries made by the academics into something that is now a real industrial project, a real industrial exploration with a significant amount of money. And so the investors are very interested by what we are doing. And the amount of money that is now on this subject is at an industrial stage. It's too low, but it's significant. So this step from the knowledge in the academia to the industry has been done. And the people now in the industry are reading the paper made by the academia where you can find hydrogen. So there is a lot of paper in the scientific literature where it was already described that hydrogen was present. The paper also explaining the mechanisms of production of hydrogen with rocks. In fact, we have those papers since, I will say, 25 years. So on a nice description of, for example, my favorite reaction was the serpentinization. So the serpentinization is the name of a reaction that produces hydrogen. And this reaction is well known by the academic world, I will say, since maybe 30 years. So we have a lot of literatures, but now what is interesting is not only researchers are reading those papers, but also engineers in the industry, and so this big jump, this big step has been made, and so I will say we are in a very interesting process where science was before the discovery, because sometimes in the human history, discoveries have been made by chance, without any science. And for natural hydrogen, science was before the development of an industrial exploration.
In this context, what are the most promising areas for future research and development in natural hydrogen?
Now, definitely we need to drill at first and drill deep. But we need to have companies open to share their data, because if they are doing a discovery on the parameters that have been discovered to make this discovery are not shared, of course, this company has a monopoly and will continue to develop itself. But I think it can slow the process of discovery at a high level. So if we can calibrate our model, geological model, geophysical model, geochemical models on a big discovery, this calibration made by the company, but the company with the help of the academic world to develop new tools, new numerical tools, new chemical tools, I think this will be very important. This calibration phase is very important, and we are now waiting for that. For example, the Mali case is interesting because we have several papers in the scientific literature on that, but some very important parameters like the volumes are still missing. So it's difficult to calibrate a geological object without the basics data that are the volumes, the capacity of production we have in this case. So we need to have those data, and this will help our sector to move faster, because if we are able to calibrate one project completely and give also the economics of this project, then it will be more easy for the investors to say, okay, here there is really a potential. And now, because I know a first calibration, a complete calibration on the volumes, on the production rates, on the money I can do with this project, so then everything will be more easy. So that's first, this good connection in between industry, good project on academy is very important. I think this is done already. We have a very active global ecosystem, including investors, industry, and the academics. So this is done, but we need to reinforce those collaboration for that. Another point is something I am working on, is the stimulation of production of hydrogen from rocks. And we have already, and it's something I am trying to develop in a new company. We know already that it's possible to enhance the production of hydrogen from rocks, because we can play with the kinetics of dissolution of the minerals, and we can play with the kinetics of production of hydrogen. So we have some parameters for that, and we know which type of catalyst can be used to enhance the production of hydrogen from rocks. And this gives you a potential of production that is more than what the Earth is doing. So we can help the Earth to produce more hydrogen. So that's a very important axis of development. And the US Department of Energy, with the ARPA-E project program, has put on the table $20 million to help several teams to develop this question of the enhancement of the production of hydrogen from rocks using different techniques, playing with temperature, playing with the surface of rocks you have in your system, and also with some catalyst that can help the production of hydrogen. So it's something completely new. And my company is a partner of one of the projects funded by the US Department of Energy.
How can the international collaboration enhance natural hydrogen research, regulation, and commercialization?
Yeah, in fact, we have already an international ecosystem for natural hydrogen. The exchange are very important in between groups, and we have now dedicated meetings, congress for natural hydrogen. Maybe you know, we have in November this HNAT summit in Paris, and so Isabelle Moriti is the leader of this congress, but I am also in the scientific team for the organization of this congress. And we have 2 days, and it will be a system completely with industry, with academics, 2 days of discussion to have a very nice place to exchange about the new results in the area of natural hydrogen exploration, and all what is around, so the economic system around us, how the industry is developing interesting project, and yeah. So that's an example. And now in some geological congress or oil and gas congress, we have dedicated days for natural hydrogen. So the places where fluent level of exchange is possible are very good, I think, now. And in the group I lead for the International Energy Agency, we have also more than 30 experts of natural hydrogen working together. And it's very, very interesting. It's very interesting to lead that, because the people are so fascinated by this subject, so motivated by the subject, that they are working so hard on it, that we have very, very interesting results. And the exchange of ideas are very, very important.
Let's get back to you a little bit. I'm very intrigued and interested. How and why have you chosen the journey of natural hydrogen?
You know, I am a researcher, so I am curious. So my motivation is to do new things. And in all my career, I have tried to move every 6-7 years from one subject to another. So I have worked from different kind of natural energies, in fact. And my motivation is also to use the tools I know, so the tools of the geology, the geochemistry, to contribute to a better future. And I'm convinced, but I'm not alone with these convictions, is that hydrogen can be a solution to the energy crisis and to the climate crisis. So really, if we can produce hydrogen in a natural way using what the Earth is given to us, is just fantastic, because it's cheap. It's, in fact, you find natural hydrogen all around the world, so you will not have, a very localized production with a country will be very rich with natural hydrogen, but it will be the only one. No, I think you will find hydrogen all around the world. So it's very something maybe given to everybody, almost everybody, I will say. So it's so my motivation, it's linked to that, to contribute to at my little place with my little energy to this effort of the humanity to solve the problem of the energy crisis and the climate crisis. So that's the first motivation, and then because I am curious and because it's challenging, I think this subject is difficult, and you need to develop new knowledge. You need to work hard on the data to find the right place. And my ambition is to contribute to that and to solve a new challenge in this energy quest we have. And that's just fascinating, I think.
Can you tell me how are you helping your clients, and who can become your client?
So what I am doing with clients all around the world is to help them to develop their skills. My clients are companies who are doing already geology, geophysics. They have good skills, but they need to develop specifically their mindset to this new subject. So for that, we are organizing trainings with theory and also in the field. And so we are going to the field, and we try to help them to have the right methods to avoid the artifact I speak before, because you can make a lot of mistake and waste your time. So you need to have good methods for the measurement, and you need to have a good integration of your geology, geophysics, and geochemistry. So what we are doing is to also make review of the data they have. So my clients are asking me they have a data set. They suppose it's interesting for natural hydrogen, and they want to have an independent and expert vision of their data set. So I am doing that for some petroleum companies. So we have done last month a very interesting field trip with Petrobras, the Brazilian company. We have that also for the Austrian company next month in the Pyrenees too. So it's training of the people, review of data set, advice. In some case, because I have also software and I am doing calculation, so we can do geological or hydrogeological models. We can do also, because I have partner for that, we can go from the data set to an economic model. So I am working also with people who have already an economic approach of the production of natural hydrogen. So I try to link everything from the beginning, so the basics of geology, to an economic project. So we have this integrate approach. And the idea really is to have this integration of all the parameters. We are not only on soil gas measurement, for example. We can do that. We know precisely how to do good measurement, but we want to integrate all the chain of the value for natural hydrogen project.
How can people reach you?
Oh, it's very easy. You can find my website, so lavoisierh2.com, or where you find the address, email address, and you can have easily contact with us. I think it's finding my name on with my name on natural hydrogen. You should find my website.
For sure, and I hope people will follow your advice. Eric, thank you very much for being my guest today. It was more than insightful.
Thank you so much for your questions. It was very interesting.
Thank you, and hope to talk to you soon.